All right, folks, last lesson of the unit, last lesson of the year. Let's do a good job here. We're talking about inscribed angles. So there's a fancy word here, inscribed angles. These are angles whose vertices are on the inside of a circle. The vertex is on the circle, and the angles are drawn through the circle. So it'll be kind of an interesting approach here as we think about this concept. All right, so an inscribed angle versus a central angle. Here is kind of just fundamentally how these are related to one another. Here we have an intercepted arc and we have an inscribed angle. The vertex is on the circle. That vertex can be anywhere as long as it's still intercepting this arc. There's two chords who meet at the circle and intercept an arc. A central angle, on the other hand, has its vertex at the center of the circle. It still has an intercepted arc. In this case, RK is the intercepted arc. That would be a central angle, ROK, an inscribed angle, ACB. All right, again, the way that we name angles is we use 3 letters with the vertex in the middle, 3 letters with the vertex in the middle. You can switch those letters around if you need to, as long as the vertex remains in the middle. So this is an inscribed angle, whereas that drawn is a central angle. Hopefully the monikers make good sense to you. All right? And what we should learn here, and what we should believe and understand, is that the measure of an inscribed angle is half the measure of the intercepted arc. So think about this. If I were to locate, randomly, I don't know if this is quite accurate, but if I were to locate the central angle that intercepts arc AC, then we should notice that it is roughly twice the size of this smaller angle ABC. All right, the inscribed angle is half the measure of the intercepted arc, whereas the central angle is equal to the measure of the intercepted arc. So that's going to be just a one little twist that we'll just have to keep our eyes alerted to, and then, of course, aware of from a computational perspective. If we know this arc, and let's say that this arc was, let's say it's 90 degrees, then half of 90 degrees would mean that the measure of this angle is 45 degrees. Likewise, if we knew that this was 45, but we needed to find the measure of this arc, we would say 45 is half of that arc. We'd have to double both sides to find the measure of arc AC. Thinking about that both forwards and backwards. If we know the arc, to find the angle. If we know the angle, to find the arc. Okay, we work those forwards and reverse when we're finding their measures. So here is an example. Go ahead and draw this picture to the best of your ability. Pause the video whilst you do that. And then let's chat about how to find the values of these variables. All right, if you haven't paused the video, go ahead and do that. And then hopefully unpause when you're done. All right, so here we have 60 degrees is the measure of this angle, this inscribed angle, angle PQT. Angle PQT's measure is half the measure of its intercepted arc, PT. All right, so I'm going to write that out using kind of this geometric notation. We have angles, we've got arcs, and we know the measure of angle PQT. It's 60. And the measure of arc PT is A. Now, how do we solve this equation? The way that we solve this equation is we multiply both sides by 2. And that tells us the value for A and also the measure of arc PT. So now we know that this is 120 degrees from point P all the way over to point T. Next, we want to find the value for B. Well, B is an inscribed angle whose intercepted arc is PS. And so the measure of angle PRS is equal to half the measure of the intercepted arc PS. Now I'm going to say PS and not PTS because this does not appear to be greater than 180 degrees or equal to 180 degrees, right? We can tell it's 150. All right, but so we're not going to use 3 letters. However, we are going to understand that the measure of arc PS is equal to the measure of arc PT plus the measure of arc PS, all right, using that arc addition to get 150, all right? The measure of angle PRS is B. The measure of angle PS is going to be the measure of arc PT plus the measure of arc TS. So we have kind of like another step of work to do or another step of thinking. I think it's important that I at least show this step. If you just wrote 150 here, that would be fine. But in the interest of doing a good job explaining that this is 120 and that this is given to us as 30, we know that B is 1/2 of 150, and therefore B is 75 degrees, all right? Or angle PRS's measure is 75 degrees. We can just say B is 75 because the degrees are already included there. So we've solved for B, we solved for A. Watch that example again if you have questions or confusion. Here are some corollaries to this theorem. And these are a little difficult maybe to imagine. Hopefully it's not too difficult for me to explain or for you to understand. But here are 3 quick concepts or corollaries to that theorem that we just discussed, that the measure of an inscribed angle is half the measure of the intercepted arc. So 2 inscribed angles that intercept the same arc are congruent. So think about that. If I have an arc here that measures 60 degrees, all right, then that means any intercepted arc would have to be half of that, would have to be 30 degrees, no matter where it's drawn, okay? And so, the way that we're going to draw that is if I draw this right here, that would be 30 degrees. If I draw it over here, that would also be 30 degrees. If I draw it over here, these are also 30 degrees. If I draw it over there, this is also 30 degrees. Can you tell that those angles at least appear to be congruent, even though it's a sloppy drawing? You get the idea that if we have the measure of this arc that is consistent, then no matter where I put that vertex, we are going to have the same angle measure. It's always going to be half of, if this is 60, it's going to be half of 60, it's always going to be 30. If it's a different angle measure, it's going to be half of that different angle measure. But these are always going to be the same. If I draw it over here, hey, those are going to be the same as well. And you can kind of tell that those angles at least appear to be congruent to one another. An angle inscribed in a semicircle is going to be a right angle. And this is kind of fun. If you draw a diameter, no matter where I draw our inscribed angle, let me grab a marker that's a different color. No matter where I draw my inscribed angle, bloop, bloop, it's going to make a right angle. What? I can draw it over here, bloop, bloop, right angle. All right? Because it's going to be half of 180. All right? So that will always be a right angle if the angle is inscribed in a semicircle. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So inscribed in a circle. We just talked about inscribed angles. So this is an angle who is contained within the circle. A quadrilateral inside of a circle, even if it's kind of wonky, if you think about it, this angle right here is half of this major arc's measure, all right? And then this angle is going to be half of this minor arc's angle. Well, together, those are going to be adding up to half of 360, which is 180, which means that they are supplementary. If I did not do a good job explaining that, please make a note in your notes to ask me about that in class, and then we'll go into a little bit more detail. I mean, I thought that was a pretty good explanation, but who knows? Who knows? All right, and we can prove that if we want to. We can do some exploration and explanation there. So here are a couple examples. I'll do a couple of these, and I'll probably save one for you because I care that you get some practice. This is our second example, and there are 3 parts to this. And so our job is to find the measure of angle 1 here. So the measure of angle 1, guess what? All this other stuff is garbage. It's all useless to us. This is a diameter. This is inscribed in the diameter. That means that it's a right angle. Its measure is 90 degrees. All right? If this is 60 and this is 80, these are going to be half of 60 and half of 80, so we know the grand total there is 70. We also know that these, angle 3 here, is inscribed in a semicircle, so this has to be a right angle. And these are opposite angles, so they have to be supplementary. And so this is also going to be a right angle, 90 degrees. All right? And then these, angle 4 and angle 2, are going to be supplementary because they are opposite angles in a quadrilateral that is inscribed in the circle, that third one. And so these are going to be 110. This is going to be 110 because these are supplementary. So the measure of angle 1 is 90. The measure of angle 2 is 110. The measure of angle 3 is 90. And the measure of angle 4 is 70. All right? The opposite angles are congruent. Are supplementary. We know that these are both 90 because they are inscribed along a diameter. All right? And so we can tell that this is a semicircle, and this will be half of that semicircle using that second rule, or that second corollary from the previous slide. I would like for you to think about and think through how to answer this third one. So make sure that you finish that one and label it in your notes. All right, this is the last concept here. The measure of an angle formed by a tangent, segment, ray, line, and a chord is going to be half the measure of the intercepted arc. All right, so the measure of this angle here is going to be half the measure of arc BC. Likewise, on the other side of the tangent line, all right, the measure of this angle is going to be half the measure of that intercepted arc. These angles are going to be supplementary. They're both going to be half of the intercepted arc, and so together they are half of 360. All right, so they make a straight angle together. So we can kind of consider that and think about that as we explore and apply this in terms of these next two examples. I will do this one. Your job will be to do the next one. So in this situation, we've got KJ is tangent to the circle. Find the value of these variables, x and y. So the first thing that we're going to do is I'm going to try to handle what's going on here with the triangle, because I know that this is a diameter because it goes through the center. That means that this inscribed angle, QJL, is a right angle. QJL is a right angle. Now, usually when we're talking about tangents, we're thinking, oh, the tangent line is perpendicular to the radius. Well, I'm not drawing this segment that is also perpendicular to the radius. I'm sorry, this radius that's perpendicular to the tangent line. That's not going to be useful to me here. All right? I know that we talked at length in the last lesson about how this tangent segment is, or how the segment is perpendicular to the radius. But we're going to use the fact that this is a right triangle to find out that y is equal to 55 degrees. The way that we do that is 90 plus 35 plus y is equal to 180. We subtract 90 from both sides. 35 and y equals 90. When I subtract 35 from both sides, I'm left with 55 for the measure of that angle. All right, so this is 55 degrees, which might be useful, it might not be. But if this is 55, then that means that this arc is 110. That's actually not necessary, but we can use that. If we know that this inscribed angle is 35, that means that this arc here is double that, 70 degrees. And so x is half of the intercepted arc, half of 70, which means that x is also 35 degrees. Boom. All right? And so think through that. If you need to write down equations to make sure that you can solve for y and solve for x, then please, by all means, do that. I would like for you to draw this picture to the best of your ability, and I would like for you to answer these questions. RS and TU are diameters of circle A. Line RB is tangent to circle A at point R. Find the measure of angle BRT. Angle BRT is this angle right here. And find the measure of angle TRS. You're going to find the measure of that angle as well. Go for it. Do a good job. Show your work. Find the measures of those angles. And write down any questions or concerns that you have into your notes.